Hello, this is Shailaja.
Hi, this is Shravya.
So today we're gonna perform image classification using Keras. So for this image classification, we're gonna use CIFAR dataset, CIFAR 10 dataset. So first I'm importing all the libraries that which we want for performing image classification. And here, as you can see, we are loading the data from the CIFAR 10 into the variables train and test. After that, I'm just defining the classes. These classes are there in the CIFAR data set. There are totally 10 class names. Next, I'm just gonna plot the images for the confirmation and our understanding that the images are loaded and uh,
Sorry.
how they're exactly coming. So I just took the first 12 images and just printed it on four rows. So as you can see the output here, it is showing along with the label. Next, I'm printing the shape of our train and test train data. So next, we are going to process our data. So before going for model training, we are going to pre-process the data of our images. So the image data is a matrix. It is in the matrix format. It is a wide range of numbers. So we're going to pre-process it using the normalization, where we are converting our image into the float, and we are dividing it by 255, which is RGB color number. So by performing this, we can bring our image data into a smaller range to predict. For example, if the range is from 0 to 1 to 100, there is a lot of gap in the to predict. If we are just normalizing it will be just 0 to 1. So it is easier to understand and predict also. After that, I'm just flattening this Y-train data, because since it is a NumPy array, we cannot perform all the operations. I'm just printing the number of classes here. It is 10. It is nothing but this class names. I'm just printing these class names. These are 10. I'm just printing the number of it here, 10. Now I'm gonna define hyperparameters for modeling our data. So this hyperparameters are nothing but the batch size, epoch size, number of classes, image height, image width. These are all our hyperparameters we're going to use today. So batch size is 100. I've took 100 for every time the model trains. It takes 100 of a batch from the load data. Next, the number of classes is 10. This I've took 10 because the data itself has 10 different types of classes. Next, epoch size is 10. We can also take 7, 15. So if we take 15 uh, or 10, it's based on the number of epochs. As it increases, the accuracy also increases, but it's a bit of a time consuming if there are number of large number of epochs. Next, I took image height and image width as 32 because as we can see, the shape of the data set is 32 here we can see. So I took that image height as 32 and 32 width and height. After modeling, next after defining the parameters, I'm modeling the data. So the pre-processing is completed and we've also got the hyperparameters. Now we are going to model the data using the sequential Keras model. And here I'm initializing the sequential object, where I'm creating also the layers. This I'm just gonna repeat the same layers 3 times, and also after that I'm gonna do a flatten layer and also dense layer. The activation I'm using here is ReLU. And after initializing and layering, I'm gonna train the model using this ADAM optimizer, and loss is sparse categorical cross entropy. We can also use only categorical entropy, but here we are using sparse categorical based on our data set. And after compiling it, training it, we are just gonna see the summary, how exactly is our output shape. So this is the first time it is 32, next time it is 16, 4. This continues for the 3 times. Next, we're gonna fit the model by giving her hyperparameters. So this plays a major role. So here we are giving batch size as this as the variable which we have declared earlier. After fitting the model, this epoch runs 10 times because we have given the parameters epoch 10 times. As you can see, as the epoch goes on, the validation accuracy is increasing. First it was 0.5, next is 0.6, and finally for 10th it is 0.72, and accuracy is 0.83. So now we're going to visualize a model so that we can see our accuracy and loss. How much accuracy is the data and how much loss was there in the data. So we can, by visualizing, we can observe and see whether it is overfitted or underfitted. So this our model. This is the accuracy. We're gonna accuracy and loss. We're gonna plot it. This is nothing but we are just giving the details, how much figure size it should be, what are the labels, what are the title, just the basic data. The output, as you can see here, there are two colors, and we've given the blue color is training accuracy and this orange is validation accuracy. As we can see, there is no drastic plot where the blue color is going up and the loss is going down. I mean, the validation accuracy is going down. Uh, so the training and validation accuracy is almost the same. Uh, we can say that it is not overfitted or underfitted. It is a good model. If otherwise, these two uh, curves are one is increasing and one is decreasing, or they are far apart, we can see we need to perform again some some more methods such as data augmentation, where we just tilt our images and create more data and train it again. But here there's no need of it, since it is a good model what we've performed. Next, I'm just printing the class names before going to prediction of new images, which we are taking from the external source, not from our training or test data. So for that, we're gonna need an image URL, external URL, and for that URL, we're gonna give a path, and we're gonna pre-process that image using the path, and then we're gonna predict it. So as we can see, for the first image, I've took a URL which is a dog. As we can see, we know that it is a dog. Next, so image prediction, we are pre-processing it, giving a path, and we are predicting it. We are just passing this image array. After that, this code is nothing but the accuracy, how much accurate our prediction is. And also I'm plotting the image. It is showing this image is most likely belongs to dog with a 23.20% confidence. And it is also printing the label and also the image. Second image prediction is a cat. So as you can see, this is a cat output, and the output says it belongs to a cat, and also the printed. The third image is of an aeroplane. So fourth image is a truck, and fifth image is a horse. So like this, we have predicted 5 images which I've took from the external source and predicted it. Next, we're gonna save the model. As with this, we can give as any name, and I'm just loading the model again. So this is what we have implemented in our ICP for the image classification. So thank you.